Now we will study the sub-branch structural engineering. It is the sub-branch of civil engineering which deals with the safe and economical design of various structures, structural members and the connections like rivets, welds and the bolts. The applications of this sub-branch are as follows. Firstly, the design of RCC, that is reinforced cement concrete structures, and the steel structures can be done by using the knowledge of structural engineering. Secondly, this subject helps to ensure proper factor of safety for various members of the structures. Means whatever the load is there taken for the design of a particular member of a structure, the load is increased by some factor like 1.2 or 1.5, and for the increased load that particular member is designed. So before designing any structural member, certain factor of safety is required to be chosen so that the member will not fail in case it is loaded by an amount more than for which it was designed. Also, the design of special types of RCC and the steel structures can be done by using the knowledge of this subject. For example, the design of dams, mobile towers and the transmission towers requires the knowledge of this subject. This particular slide shows you the famous structure of Paris, which is called as the Eiffel Tower, as well as in the second picture you can see a mobile tower, and the third picture shows you an RCC multi-storied structure. So in the design of these structures you will need the knowledge of structural engineering. The next sub-branch we have is irrigation engineering. It is the sub-branch of civil engineering which deals with the supply of water to the areas scanty of rainfall. Means the places where the rainfall is lesser will require the supply of water through canals or some other ways. The applications of this sub-branch are as follows. Firstly, the sprinkler irrigation and the drip irrigation. In the sprinkler irrigation system, water is sprinkled in the form of droplets and it is delivered to the crops. Since the water is sprinkled in the form of droplets, only the required quantity can be supplied to the crops and the excessive use of water can be eliminated. Similarly, the drip irrigation system ensures that the water is delivered only at the root of the plants, which will again help you to eliminate the excessive use of water. This particular slide shows you the sprinkler irrigation system in which the water is getting sprinkled over the entire farm. Here what happens is that if you deliver the water through channels to the crops, most of the water will percolate down into the soil and it will get wasted. So to eliminate the wastage of water, if you supply it through the channels, the sprinkler irrigation system is developed. Similarly, the next photograph shows you the drip irrigation system in which the water pipelines are laid along the row of the plants and there are holes to each pipeline at the location of root of the plant. So water will be delivered only at the root of the plant and not at the other locations. The second application of irrigation engineering can be to decide the capacity of the reservoir. So if you calculate the area of the reservoir and the average depth, you are able to calculate the capacity of that particular reservoir. The design and construction of different types of dams like earthen dams and the reinforced cement concrete dams can be done by using the knowledge of this particular subject. Similarly, the other structures like canals or weirs or spillways can be done by using the knowledge of this subject. Here, weir is a structure which helps to control the flow of water in a canal. So, at the location where a canal starts from the dam reservoir, a weir is constructed, and that weir will help you to control the flow of water through the dam reservoir into the canal. So weir is provided at the junction or at the place where the canal starts from a dam reservoir. Also, spillway, we have already discussed that it is a structure on the downstream side of the dam which helps to take the water or glide the water smoothly on the other side whenever it overflows the dam. So whatever the water of the river overflows over the top of the dam is taken to the another side by providing a smooth slope on the downstream side of the river, and the water will glide smoothly over the slope, and that portion is called spillway. Now we will see in detail the geotechnical engineering. It is the sub-branch of civil engineering which deals with the study of soil and its behavior under the application of the loads. Basically, the word geo means soil. The applications of this sub-branch are as follows. Firstly, it helps to determine the strength characteristics and the properties of the soil. The soil is studied with the help of its properties like voids ratio. Voids ratio is a ratio of volume of voids or empty spaces within a soil sample to the total volume of the soil sample. So once you know the voids ratio or the amount of empty spaces in the soil sample, you will be able to calculate its strength. Similarly, density index is one more property of soil which will help you to get the idea regarding the quality of the soil. Also, the knowledge of this subject helps to classify the soils and thereby to predict the different uses of that particular soil. The soil can be classified on the basis of the sizes of its grains. So starting from the smaller grain sizes, we can classify the soils as the clay soil, the sandy soil, the gravel and the boulders. Also, to determine the intensity of the stresses at various depths below the soil, you can use the knowledge of this particular subject. Also, you can assess the capability of subgrade of a road, and you can calculate the thickness of various layers required in a pavement. Now the next sub-branch we have is foundation engineering. It is also a sub-branch of civil engineering which helps to design and construct different types of foundations for buildings and the bridges. The applications of this branch are as follows. Firstly, you can explore or you can excavate the ground, and you can know or you can get the idea regarding the quality of the soil available at different depths. And once you get the quality of different soil samples at different depths, you can know the depth of the foundation required, because for any structure like buildings or bridges, the foundation of that structure must be constructed on a hard rock. So you will be able to know at what depth below the ground hard rock is available.